Hi dear students, welcome to Gita's classes. In this class, we are going to see inverse Laplace transform using second shifting theorem. So, first of all, we should know if L of f of t is equal to f bar of s, then L inverse of f bar of s is equal to f of t. This relationship, please remember and try to remember the following formulas. All these formulas with the proofs are available in my channel in the previous classes. Please go through them because you have to be thorough with Laplace transform, then only we can find out the inverse Laplace transform easily. And these are the inverse Laplace transform of some elementary functions, standard functions. So try to remember these formulas, and linearity property also is important so that we can use them in the problems. Okay. Now coming to second shifting theorem, we know that what is second shifting theorem in Laplace transform? Laplace transform of f of t minus a into u of t minus a is equal to L inverse of e power minus as into f bar of s. This only we are using L inverse of e power minus as into f of s is equal, f bar of s is equal to f of t minus a, u of t minus a. So how are you going to apply in this problem? Whenever you want to find out the inverse Laplace transform of some functions which are multiplied by e power minus as, then you have to recollect that we are going to apply second shifting theorem. So it should be multiplied by e power minus as. Okay. Then without this e power minus as, our f of s, we will get f bar of s. Now you can find out L inverse of f bar of s. What will you get? F of t. Okay. And from this e power minus as, find the value of a and write the function f of t as, in the place of t, replace it by t minus a, and you will be getting f of t minus a. Also just multiply it by u of t minus e. Okay. U of t minus a is our Heaviside unit step function. So either you can write it as f of t minus a into u of t minus a, or if you want to expand it, then you can multiply like this, f of t minus a if t is greater than or equal to a, and 0 if t less than a. We have in the second shifting theorem of Laplace transform, I have explained about the unit step function also. Okay, if you have any doubts, you can go through that. So now let us see some problems. Find L inverse of 1 plus e power minus pi s divided by s squared plus 1. So here we have, using linearity property, I am going to split them into two. That is L of 1 by s squared plus 1, L inverse of 1 by s squared plus 1 and e power minus pi s by s squared plus 1. So L inverse of 1 by s squared plus, let it be equation number 1. Okay. So now this one we know it is sin t plus L inverse of e power minus pi s. Let us find out. For the second term, e power minus pi s, consider L inverse of e power minus pi s into 1 by s squared plus 1. So here what is our f bar of s? It is 1 by s squared plus 1. Okay. Implies f of t is equal to L inverse of f bar of s, which is equal to L inverse of 1 by s squared plus 1. S squared plus 1. What is L inverse of s squared plus 1? We know that it is sin t. Okay. So f of t is sin t. What is our a here? Here a is equal to minus pi s. So a is equal to pi. Okay. Therefore f of L inverse of e power minus pi s into 1 by s squared plus 1 is equal to f of t minus a into u of t minus a, according to second shifting theorem, right? So here what is a? Pi. So f of t is what? Sin t. So sin of t minus pi into u of t minus pi. A is equal to pi here. Therefore substituting in equation number 1, we get That is, in the second term only we have found out like this. Okay, so first term is sin t. So L inverse of 1 plus e power minus pi s by s squared plus 1. This is our required function. This is equal to L inverse of 1 by s squared plus 1 plus L inverse of e power minus pi s by s squared plus 1. So which is equal to sin t plus sine of t minus pi into u of t minus pi. That is equal to sin t plus sine of t minus pi. I can write it as minus sine of pi minus t. Okay, minus sine of pi minus t. What is sine of pi minus t? It is sin t. Okay, so it is sin t into u of t minus pi. So I can take sin t outside, sin t into 1 minus u of t minus pi I can write. So this is the answer. So for the first one you have sin t, and the second term you have sin t into sine of t minus pi into u of t minus pi. This can be simplified like this. Okay, so this is the answer. And next one, find L inverse of e power minus 3s by s minus 4 the whole squared. So here a is equal to 2 e power minus as. Whenever it is multiplied by e power minus as, please remember you are going to apply use second shifting theorem. So here a is equal to 2 and f bar of s is equal to 1 by s minus 4 the whole squared. It is very simple. Find L inverse of f bar of s. That is our f of t. Okay, so f of t is L inverse of f bar of s so L inverse of 1 by s minus 4 the whole squared, which is equal to e power 4t. S minus a, s plus a or s minus a form means first shifting theorem. So e power 4t into L inverse of 1 by s squared. That is t into e power 4t. Okay, e power 4t into L inverse of 1 by s squared is t. So t into e power 4t. Okay, what is this? F of t. So what is our required function? L inverse of e power minus 3s by s minus 4 the whole squared is equal to f of, by second shifting theorem, f of t minus a into u of t minus a. So this is our f of t. In the place of t, you have, wherever you have t, you replace it by a is equal to 2. That is t minus 2 into e power 4 into t minus 2 into u of t minus 2. That is the answer. Okay. So e power minus 3. Here a is equal to 3, not 2. I'm sorry, here it is 3. E power minus 3s, so it is 3. Okay. T minus 3 into, wherever you have t, replace it by t minus a. So t minus a is equal to 3 here. So t minus 3 into e power 4 into t minus 3 into u of t minus 3. This is the answer. That is equal to, or if you want, you can write it as t minus 3 into e power 4 into t minus 3 if t is greater than or equal to 3, 0 if t is less than 3. Okay. This is enough. In this step you can stop. If you want to write, or if it is asked for proving like this, then you can write like that. Okay. Next question. L inverse of e power minus 2s by s squared plus 4s plus 5. You can pause the video and please try on your own. Okay, then you can verify the answer. So it will be a practice for you if you do like that. So now f bar of s, here what is a value? A is equal to 2. E power minus 2s, so a is equal to 2. And f bar of s is equal to 1 by s squared plus 4s plus 5. So f of t is equal to L inverse of f bar of s is equal to L inverse of 1 by s squared plus 4s plus 5. Whenever you have quadratic in the denominator, try to write it as s plus or s minus a, s plus a or s minus a form. So 1 by, here you have, how will you split them? You have to take from the constant. So here it is 4, that means 2 into 2. So this 2 squared we want. Okay, so 4 plus 1. 2 squared is 4. So split 5 as 4 plus 1. So 1 by s plus 2 the whole squared, or first one more step you can write s squared plus 4s plus 4 plus 1. Okay, that is L inverse of 1 by this 3 terms I can write it as s plus 2 the whole squared plus 1. Okay, that is, now you have to use, if it is in the form of s plus a or s minus a, first shifting theorem. So you have to take e power minus 2t s plus 2. So e power minus 2t outside into L inverse of 1 by s plus 2 will become s. Okay, so s squared plus 1. What is this? Our f of t. So this is equal to e power minus 2t into, this is L inverse of 1 by s squared plus 1 is sine. So this is our f of t. Therefore, by second shifting theorem, we have found out f of t. So you have to write it as f of t minus e. So L inverse of e power minus 2s divided by s squared plus 4s plus 5 is equal to f of t minus a into u of t minus a, right? What is a here? Where a is equal to 2. So f of t is this one, e power minus 2 into, wherever you have t, replace it by t minus 2. So minus 2 into t minus 2 into sine of t minus 2 into u of t minus 2. This is the answer. Okay. Next question. L inverse of 3 plus s by s squared into e power 2s. In the denominator, e power 2s is in the denominator. So just to confuse you, they will give like this. You bring it to the numerator. It will become e power minus 2s into 3 plus s by s squared. That's all. Okay, now you have to e power minus as into some function should be there. Then only we can use second shifting theorem. Okay. So here a is equal to 2 and f bar of s is 3 plus s by s squared. So what is our f of t? First you find out f of t. F of t is L inverse of f bar of s is equal to L inverse of 3 plus s by s squared. By using linearity property, I can split them. 3 into L inverse of 3 by s squared plus L inverse of s by s squared. That is 3 into L inverse of 1 by s squared plus L inverse of 1 by s. That is equal to 3t plus 1. What is this? This is our f of t. A is equal to 2. Therefore, L inverse of e power minus 2s into 3 plus s by s squared is equal to, by second shifting theorem, f of t minus a into u of t minus a, where a is equal to 2. What is our f of t? 3t plus 1. So 3 into 3 into t minus 2 plus 1, right? Plus yes, 3 into t minus 2 plus 1 into u of t minus 2. This is answer. Or you can write 3t minus 6 plus 1. So minus 5 into u of t minus 2. Okay. Or you can write, if you want to expand it like that, then 3t minus 5 if t is greater than or equal to 2 and 0 if t is less than 2. Not 0, 2. Okay. So this is what about second shifting theorem. So when will you use? If it is if the function is multiplied by e power minus as, remember you have to use second shifting theorem. Okay. Hope this will be useful to you. Please give a like and share it with your friends so that it will be useful for them also.